Hello everyone, so in this video we're going to do something a little bit different. So in the past few videos we talked a lot on simple harmonic motion. We covered the theory, and good news is we have actually covered everything that's in the syllabus. The only thing that I have not covered yet is how to derive the velocity function. Not with respect to time, it's the one that has x in the equation. So I'm going to put that on hold for a bit because I do realize that Cambridge A-level physics paper is around the corner. So I thought, why not we practice some questions. So today we'll be looking at one of the questions from winter 2024, question paper 43. It's a very recent paper actually, and it's question 4. Okay, so they ask you to state what is meant by simple harmonic motion. I'm going to skip this question. The reason being is its definition is something that you should know before you enter the exam hall. And if you understand the concept of simple harmonic motion, you'll be able to answer this question and you'll get your 2 marks. So do not miss those definition questions. Make sure you understand your definitions so that you can score all those definition marks. Okay. We'll now move on to the best part of the question. This is B. A block is suspended from a spring as shown in figure 4.1. Okay. So this is the spring, you have a block. Next thing, they said the block is pulled down and released at time t equals 0. It then oscillates vertically with simple harmonic motion. Okay. Figure 4.2 shows the variation of the velocity v of the block with height h above the base of the block, above the floor. Okay. Alright. So before we go on further into answering the questions, let's understand what this graph is about first. It will be really useful later on because some people might take this as a velocity against displacement graph. So if you did not read properly and you assume this was v against displacement graph, you're going to misinterpret the graph a lot and you might even get confused. So read the instruction and the question properly. They said here, the figure shows the variation of velocity with height h of the base of the block above the floor, which is this height here. They did not say is displacement. So don't get overexcited and think that is a displacement and proceed to answering the question. You will not be able to get any answer. So read properly the question. Okay, now let's look at this graph. So we have found 2 points where v is equal to 0, which is this point, and your h here is around 3.5. And here also your v equals to 0, and your h here is around 9.5. And the next thing we have is our maximum velocity, which is this, because that's the maximum, right? Which is 9.5, or even here also, it's 9.5. And it's at this particular height, which is around 6.5. H is 6.5. I'm going to just mark here, and your V is equal to 9.5. Okay, another thing to check is your units. Is both your units are the same? If it's the same, you are good to go. If not, you need to convert it later. Okay, now let's go back to the picture and see how the graph and the spring actually works. First of all, when your V is equal to 0, that means you are at the maximum height or you are at the lowest height. It's either you're the highest point or the lowest point. So they said here, the block is pulled down. So when the block is pulled down, let's say the block is now here. This will be your height, right? Then it goes here, it passes through equilibrium. This point here, we denote this as the equilibrium position. That means that is where it was. Then what happened is now they pulled it down and it's now oscillating. So when they pull it down, it was at here. then perhaps it's going to pass through equilibrium, then maybe it's somewhere here. And now, this will be your height. So what can we deduce from this? We can deduce that the lowest point, when the block is at the lowest point, your height is the smallest. Remember, your height is the h and the height of the base of the block above the floor. So, this height, h equals to 3.5, is when the block is at the lowest point. Then, it goes up, passes through the equilibrium. Remember, at equilibrium, your velocity is maximum. Right? So, this is the point here. When your velocity is equal to 9.5, your height is 6.5. Then, it goes to the highest point. Your h will be the highest, right? And it is correct. Your h, among all these three, the highest point will have the highest h. Because that's how high you are above the floor. And you get 9.5. And your v will be equals to 0. Because at the highest and lowest point, your velocity is 0. Okay, so now if I were to label this at the side, let me draw a line here. This point, it is 9.5. This point at the equilibrium in the middle, it's 6.5. Okay. And at this point here, it's 3.5. Make sure you read your scale properly. Don't accidentally read different numbers. Make sure you read them properly. If not, you might perform some wrong calculation later on. Okay? Alright. Now, this is what we know. And this is not displacement. Not displacement. Because the height is defined as the height of the base of the block above the floor. I think I've repeated this quite a lot of times. But yeah. You really need to read the question properly. Okay. So this is what we have concluded from the graph. Is there any other thing we can find out? We can find something called the amplitude from the graph. How? Okay, let's look at this diagram, this figure 4.1, that maybe we can understand. How do we find the amplitude from here? Your amplitude is actually, this is your amplitude, or this, because amplitude is the distance from the equilibrium to the highest point, or distance from the equilibrium to the lowest point. So you take 9.5 minus 6.5, you should get 3. And if you take 6.5 minus 3.5, you should also get 3. This is your amplitude. That is one way to find out. The another way to find it out is you take 9.5 minus 3.5 and you divide by 2. Because when you minus, you will get the distance from here to here, right? Then you divide by 2, you will know what is the middle point. You get your midpoint and you will actually also get 3 cm. There's actually 3 different ways to actually do this. Your amplitude is, remember, it's from equilibrium to the highest point or equilibrium to lowest point. You don't go and take 9.5 minus 3.5 but you forgot to divide by 2. So, the distance from here to here is what we call is your amplitude, and as we have calculated, it is 3 cm. Yep. So actually that's about it we can deduce from this graph. If you understand this graph the correct way, properly, and not assume that it was velocity against x, you will be able to answer all the questions here. Okay, now we can safely move to the question. Okay, Roman 1, determine the amplitude. Okay, this one we have found just now. Right, there's 3 ways. I think the answer scheme did as 9.5 minus 3.5 divided by 2 equals to 3 cm. Remember, 2 significant figure, minimum. If you write 3, you'll get it as wrong, even though the answer is correct. So don't lose marks just for the sake of you wrote the significant figure incorrectly. So it's 3 cm. Or, if you don't want to do this method, alternative is I'm just going to put ALT as alternative. We can take 9.5 minus 6.5 equals to 3, or 6.5 minus 3.5 equals to 3 cm. All these three methods is acceptable actually, because as long as you get the same answer, it's the same. It's just how you approach it, is your perspective of amplitude. Yep. Now, show the angular frequency of the oscillation is 3.2 radians per second. Okay, this one, we can actually use the maximum velocity formula. We know maximum velocity is omega, okay, let me write V max equals to omega and your amplitude, right? Or x naught, depends on what you write it as lah. But basically it's omega and your amplitude. And we want to find the angular frequency, and this is what we're basically going to find what your omega is, right? We have Vmax, we have the amplitude, so we can proceed the calculation. Your Vmax is 9.5. Okay, let me first rearrange this. 9.5. Wait. Your amplitude is not 9.5. Your amplitude is 3. Divided by 9.5. Remember, check your units properly. This is where your units need to be correct. And we have checked it just now, so we are good to go. 3 divided 9.5. Wait a minute. Oops. Okay, wait. Did I do something wrong? Oh, wait. Okay. Sorry. I think I did something wrong. You should actually write it like this. Omega equals to V max over A. Please don't do this in exam. Don't be like me and do it wrongly. Or if you don't want to rearrange, just sub it inside and find your omega. Seriously, that's the easiest way. Yeah. So your omega it's the other way around. 9.5 divided 3. No wonder I figure why my answer is so weird. You'll get 3.2 radians per second. Sure. Okay. Now we've done with question 2. Not question 2, Roman 2. Next, they asked to find the period of the oscillation. So we know omega has the formula of 2 pi over t. So given what has happened in the previous question, I'm just going to sub in the formula, the value, okay? So we know omega is 3.2, 2 pi over t. Then your t is actually 2 seconds. 2 seconds corrected to 2 significant figures. It's actually 1.96. If you want to put it as 3 significant figure, you can put it as 1.96. But 2 significant figure is sufficient enough. So that means period of oscillation means to complete one cycle. So it takes 2 seconds for this spring to complete one cycle. Okay, so we have actually scored 7 marks. That's a lot of marks. That's a lot of marks, you know. And the last one, this question is a lot of marks, 4 marks. Okay, what are they asking? On figure 4.3, I think this is the last part. Yeah, this is the last part of the question. On figure 4.3, sketch the variation of h with time t from t equals 0 to t equals to 6 seconds. Okay, here, if the first part here, you assume straight away this is velocity against displacement graph, you're going to stuck here. You're seriously going to stuck here. And you might not even be able to answer these few questions. Yeah. So, now, given the fact we have already discussed it the correct way, h being the height of the block from above the floor. So, that's to sketch the variation of h with time t from t equals to 0 to t equals to 6 seconds. Okay, they said something here with time just now. Yeah, a block is pulled down and released at time equals to 0. This means when the block is pulled down, at this point, it was t equals to 0. So it was released when it was down itself. So that means your first value should be your lowest height, which is 3.5. So your 3.5 should be somewhere here. Is that? Okay, wait, let me check. I'm not gonna assume. Oh yeah, it's correct. Yeah, it's there. 3.5 is there. Okay. Because they said it's pulled down first, right? Pulled down and it's released at t equals 0. And we know at t equals to 0 is here. And at that point, when it's at down, your height from the lower part of the block to the floor is 3.5. Okay. Then here you must take note of the cycle, because one complete cycle is 2 seconds. So you must divide it accordingly. Okay, after it goes from down, it's going to go past through the equilibrium. Your equilibrium is 6.5. I think your 6.5 is here. I think so. Wait, let me. Because I'm just roughly calculating it. 5. Oh yeah, yep. So that is where your equilibrium is. Then highest point, what's your highest point? It's 9.5. Basically, from down here, it goes here, equilibrium, then it goes all the way to the highest point. Then after that, it's going to come down here, it's going to come down here. This is half a cycle. This is another half a cycle. Together, it's a complete cycle. So now we're drawing the first half of the cycle first. So, okay, where's my green? Highest point is 9.5. 9.5 should be here. Wait. No, 9.5 cannot be there. Wait. 9.5 should be a bit lower. Here. Okay. This is half a cycle. Then, at this point, at 1.5 here, should be back to equilibrium, right? Then, it's the lowest point back. It was here. Go equilibrium. Then go highest point. Okay, highest point I put HP, lowest point is LP. Right? Then, come back to equilibrium here. All the way back to lowest point. One complete cycle. Make sure your period is consistent as well, because you calculated here 2 seconds. There's a reason why they ask you to calculate your period before. So it's one cycle. And since they give such a big space, let's continue the cycle. It's gonna be here. Make sure you plot correctly at the time. Then half a cycle is you'll be here, then go back here. Oops, wait. Here, then at 4. Okay. Then goes back up here. Then go highest point, come down here and here. Oh, basically three complete cycles. Then now we need to draw. This looks like a upside down cosine graph. Okay, my graph is not nice. Let me draw it again. Great. I see my hand is shaking. Nope, not nice. This is actually upside down cosine, yeah. Yeah, something like that. Make sure your graph touches all the points. Okay, make sure it touches all the points. And don't draw your graph like this. No, because spring is a smooth oscillation, so do not do that, okay? The most important point is basically the highest and the lowest point and your equilibrium point is very important, because that is the only way how you want to sketch the graph, right? Yeah. And there you go. You got 4 marks. Make sure it's neat, crosses all the points, no sharp ends. Okay, this looks like a sharp end here. It's a smooth end. Make sure it's a smooth end because it's an oscillation. Sure, it's smooth. And that's about it. Okay, we've actually come to an end, and if you have successfully done all the question, you would actually get your 11 marks. Easy, right? Yes, easy if you understand. Definitely. So, my conclusion is read the question and take some time to understand. It's normal to get excited when you see something you know, but it's always also good to read and understand what the question actually wants. Because if you confuse this graph with velocity against displacement, you might misinterpret it, like I said before. So that's about it for today's video. I hope this works, and I will see you in the next one. Okay, bye bye. Have a nice day ahead.